So this was a long time ago, the 5th century BC, Leucippus and Democritus. Anybody heard of them? I hadn't heard of them before I read this book. Okay, so 5th century BC, those were the first recorded ideas of atoms. And Democritus suggested that, you take a sample of matter and you cut it in half and cut it in half and cut it in half, and eventually you would get down to a smallest piece that could not be cut in half. And he called those atomos, or atoms. And that's from the Greek meaning indivisible. So there is a smallest indivisible particle. Well, other people like Plato and Aristotle, anybody heard of those guys? Yeah, you've heard of those guys. Those guys said, no, there's no such thing as an atom. You could just subdivide matter indefinitely. So we kind of got derailed there because the wrong people won the argument. So here, 2,000 years later, John Dalton, an English scientist, came up with an atomic theory stating that matter is composed of elements. Matter is composed of atoms. It's only 2 o'clock in the afternoon, and apparently my brain is tired. So 2,000 years of believing the wrong thing. Dalton's atomic theory. I am not going to expect you necessarily to remember Dalton's name. I'm not going to expect you to write out his atomic theory word for word. I want you to understand the basic ideas of his theory. The first big idea is that each element is composed of tiny indestructible particles called atoms. His second proposal was that all atoms of a given element have the same mass and other properties that distinguish them from atoms of other elements. In other words, he's saying that, all the atoms of gold are the same, and all the atoms of silver are the same as each other, but they're different from the gold atoms. And atoms of carbon, all the atoms are the same, all carbon atoms are the same, and they're different from these other elements. I think of atoms as a lot like being a lot like Lego bricks. You've got the little red Lego bricks that are 2x4, and then you could have blue Lego bricks that are 2x2. And there's lots of different kinds of Lego bricks, but they're the same as, that's not going very well at all. Okay, we'll just get off the Legos. Sorry. Sometimes those things work out and sometimes they don't. Third thing, atoms combine in simple whole number ratios to form compounds. This is a picture of atoms. So scientists at IBM, using a scanning tunneling microscope, they moved some xenon atoms around on a surface and spelled IBM. How creative, right? There's a variety of these pictures available. There's one that has the Japanese kanji characters for atom. I think that one's a little more interesting, but this is the one that's in your book. This is about as good of a picture as we can get of individual atoms. And you might say, well, man, those are kind of funny. They're sort of triangular, cone-like things. Well, they're actually not cone-shaped. They're more of a sphere-shaped. The cone shape is just sort of an artifact of how the picture is taken. They take a probe and they pass it over the surface and they run a constant current through it, and so they have to move the probe to keep the current constant, and so it goes up and down as it's going across, and then they get this digital image. This is not like a photograph or a traditional microscope where you just zoom in and zoom in. That's not possible with an optical microscope to zoom in this far. This is an electronic microscope that uses current to visualize the atom.